Okay, today what we're going to be learning about is forces and motion. So there's a few terms we need to learn to begin with. The first one is what a scalar quantity is. And a scalar quantity is when you have size but no direction. This is different to a vector quantity because vector quantities have both size and direction. So if I say something like 15 metres, we're talking about a scalar quantity. But if I'm saying 15 metres south, then we're talking a vector quantity. The next thing we'll be looking at is distance, and the easiest way to explain this is by using our little map on the left. So if we say that this here is our house and this here is the school, then the distance is the measurement of how far apart we are. So we'll look at the path we take to walk to school, and it's something like this. So the total distance for this journey will be the distance of this line here plus this distance of this line here. So if this is 200 metres and this is 150 metres, then the total distance will be 350 metres. The next thing we'll look at is displacement. Now displacement is different to distance because it's a vector quantity, so it has to have both size and direction. And displacement is a measurement of the change in position of a moving body. So it is the straight line connecting the starting position to the final position, as you can see here. So if we're looking at the displacement, we will need to use Pythagoras' theorem, which is a squared plus b squared equals c squared. So in this case, it'll be 200 squared plus 150 squared to give us c squared. 200 squared is 40,000. 150 squared is 22,500, and this is c squared. We add those together and we get 62,500 with c squared. And to find the answer of c, what we have to do is the square root of 62,500, which comes out to be 250 metres. Now because this is displacement, we need to give direction. So if we say we've got north, east, south and west, from the original position we have gone like this, so we are southwest. Now we're going to talk about speed. Speed's quite important because we need to work out how far we've travelled in a certain amount of time. So we're looking at how quickly an object is moving. The average speed equals the distance travelled over the time taken. So if we look at this original path that we took, we know that the total distance was 200 plus 150, which came out to be 350. The time taken, let's say it took 3 minutes, which is, we have to convert to seconds, so 3 minutes is 180 seconds. So your average speed is 350 divided by 180. So this gives us a speed of 1.94 metres per second. The abbreviated form of this formula is V equals D on T. It's quite important for us to be able to convert between kilometres per hour and metres per second. And the way we do this is by using the magic number 3.6. So if we want to get from speed in kilometres per hour to metres per second, we divide by 3.6. And to get from speed in metres per second to kilometres per hour, we times 3.6. So if we use the example, say, of trying to find what 3 metres per second is in kilometres per hour, then all we need to do is 3 times 3.6 gives us 10.8 kilometres per hour. The opposite, if we want to go from kilometres per hour to metres per second, let's say we're going 54 kilometres per hour, we want to go to metres per second, then we do 54 divided by 3.6. which comes out to be roughly 15 metres per second. Instantaneous speed is quite different to speed. Speed represents your average speed for the journey, whether your instantaneous speed might change over time. Your instantaneous speed is your speed at a particular instant, and a simple way of looking at this is by looking at a car speedometer. That tells you at a particular moment in time what speed you are going. The last thing we'll be looking at is velocity. Velocity is also a vector, so we're looking at how displacement changes instead of distance, and therefore, because it's a vector, it has both size and direction.